Have you ever wanted to peek behind the curtain of a program and see how it really works? That's the world of reverse engineering. In this video, we're going to break it down step by step. What it is, why people do it, where it's used, and the skills you need if you want to start learning it yourself. Reverse engineering is about working backwards. Imagine you have a finished puzzle but no box cover. You carefully study each piece to figure out how it was built. With software, we don't always have access to the source code. All we see is the compiled program, the executable. Reversing means peeling away layers of abstraction to understand its design, structure, and behavior. Think of an old video game console emulator. Developers figured out how the original system worked by reverse engineering the hardware and software. Or take a mysterious app you downloaded. You don't know what's inside until you dig into it. There are a lot of reasons to reverse engineer software, and not all of them are shady. In fact, most of them are perfectly legitimate. Some points are security research for analyzing malware, discovering vulnerabilities. Interoperability would be getting two systems to talk when no documentation exists. In recovery, we revive old software when the company behind it no longer exists. And for validation, we check that software does what it claims to do. Take malware analysis. A virus lands on someone's computer, but how does it spread? How does it hide? Reverse engineers step in, break it down instruction by instruction, and give defenders a fighting chance. Reverse engineering pops up in places you might not expect. Cybersecurity labs, corporate R&D, even hobbyist communities keep classic games alive. Malware labs tear down ransomware samples. Companies make drivers so new hardware works with older operating systems. Cryptography enthusiasts testing if an encryption algorithm is solid. Game modders cracking open executables to build new content. To really reverse engineer, you need to think at the lowest level. Forget user interfaces. You're looking at what the CPU is executing. That means assembly language, instruction sets, and binary data. For assembly basics, we have our registers, opcodes, and flags. Debuggers and assemblers are like our microscopes. Process monitoring, we're watching memory, file access, and API calls. And then in bridging levels, we're seeing how high level C code becomes assembly and machine code. Reverse engineering is powerful. And with that power comes responsibility. Thanks, Uncle Ben. Used in the right way, it defends people, recovers knowledge, and fuels innovation. Used in the wrong way, it can break laws and cause harm. Good uses would be security research, learning, and compatibility. Bad uses would be piracy, bypassing protections, or creating malware. The rule of thumb is always ask, am I using this knowledge to build or to break? So here's the big picture. Reverse engineering is about discovery. You're working backwards to see how something was built. It's used in security, research, and development. It demands low level knowledge and careful analysis. And it's a skill that comes with both power and responsibility. Again, referencing Uncle Ben here. If this breakdown helped you understand the world of reverse engineering, drop a like, subscribe to HackByte, and comment what part of reversing you want me to dive deeper into. See you in the next one.